Hi, and welcome to this short concept bite describing the concept of thermodynamic heat. Now, heat is a really common word in everyday parlance. However, in thermodynamics, it has a specific meaning. Hopefully, you recall that when I defined a closed system in thermodynamics, I said that energy could be transferred from the system to the surroundings by two methods, heat and work. Therefore, in thermodynamics, heat is a mechanism of transferring energy. Previously, I've used the term diathermic wall, but not really defined it. However, it is just a boundary through which energy can be transferred in the form of heat. I've said that heat is a mechanism of transferring energy between the system and surroundings, but how does this differ from work? Heat is defined as a mode of transfer of energy that achieves random motion in the surroundings. So, how does this look in practice? The sketch shows the system and the surroundings with the atoms in the solid surroundings shown. The temperature of the system is higher than that of the surroundings, and so there is a temperature gradient moving away from the system. The vibrations in the molecules of the surroundings become less vigorous as you move away from the system. This then sets up a temperature gradient across the system, which then redistributes the energy in the form of heat, by inducing more vibrations until the system is in equilibrium and has redistributed the energy across the system and surroundings when they both have the same temperature. In an exothermic reaction, energy is transferred in the form of heat from the system to the surroundings. The temperature of the surroundings increases and the internal energy of the system decreases. In an endothermic reaction, energy is transferred in the form of heat from the surroundings to the system. The temperature of the surroundings decreases and the internal energy of the system increases. What happens if a gas in a system is allowed to expand, do work on the surroundings? Well, from the ideal gas law, if the volume increases, then the temperature of that system has to fall. This is where our understanding of heat as a mechanism of transfer of energy is important. Here, the temperature of the system has decreased, but no energy in the form of heat has been transferred. If I want the temperature of the system to remain constant, the energy in the form of heat has to be transferred from the surroundings to the system. The case where the temperature of an expanding gas is constant is called isothermal expansion. For the reversible expansion, the amount of heat transferred into the system may be calculated. The work done by an expanding system in a reversible expansion is given by this equation, which is derived in an earlier video. The work done is negative as the energy is transferred from the system to the surroundings, lowering the internal energy of the system. If the temperature of the system is to remain constant, then the net change in internal energy has to be zero, or the amount of heat transferred into the system has to be equal and opposite to the work done by the system. Therefore, the heat transferred into the system is in an isothermal reversible expansion is given by plus nRT log Vf over Vi. This gives us a second definition of the first law in a closed system where the only forms of energy transfer are heat and work. Then the change in internal energy, delta U, is the sum of the energy transferred in the form of work, W, and heat, Q. I hope that this video has proven both interesting and informative. If you have any questions, please do not hesitate to contact me.